Start by asking yourself a question, honestly. Do you know how to distribute? Do you understand the distribution rule? So if you don't know what I'm talking about or you don't know how to distribute, we already did this twice. Please stop this video, go back and find the videos where we learned how distribution works. You need to know how to distribute in order to be able to continue any further with this course. So again, do you know how to distribute? Don't spend hours of your time being confused. Go back, find the videos, learn how to distribute, and then continue. In this lesson, we're going to learn how to factor. Factor is the opposite of distributing. So again, if you don't understand distribution, it's going to be absolutely hopeless to figure out how to factor because, again, factoring is the reverse of distribution. We're going to start with the simplest case of factoring. It's called the difference of perfect squares. And we're going to continue with this concept of factoring in the next few lessons or so. So again, last warning, if you don't know how to distribute, go back and figure it out because you need to know how to distribute if you want to understand and be able to do factoring. Factoring is at the very heart of algebra. Second problem. Now we're asked to factor, and again, factoring is to undo the distribution. So what two sums of products would this produce? And we're going to start off by writing the parentheses. What times what is going to be x squared? X times x is x squared. And then we need to get a 1. So we know we're going to have a 1 in both positions. But it's got to be -1. So 1 has to be positive. The other one has to be negative. And so we factored this difference of perfect squares, x squared minus 1 into x plus 1, x minus 1. And you can check if we were to distribute, right? We get x squared, we get -1. And then as far as the x terms are concerned, we'd have a minus x, a plus x, and you'll notice those two terms cancel out. So again, this difference of perfect squares is going to be x plus the square root of that number times x minus the square root of that number. Let's look at the next problem, x squared minus 4. So start off by writing your parentheses. The first term is the square root of this first number. So what's the square root of x squared? Square root of x squared is x. What's the square root of 4? Square root of 4 is 2. We'll put 1 plus sign, 1 minus sign, so that 2 times -2 would give us this -4. And notice again, you'd have a plus 2x, a minus 2x. Those are going to cancel out. So difference of perfect squares, x squared minus 4 is x plus 2, x minus 2. X is the square root of x squared. 2 is the square root of 4. And we're going to put 1 plus sign, 1 minus sign, and you can verify that on the previous problem. We're going to go both ways so that we get comfortable with learning how to factor and distribute because these are two operations that are very, very closely related to each other. X squared minus 9. So start to notice this. It's a difference of perfect squares. The square root of x squared is x. The square root of 9 is 3. And we need a positive and a negative. Plus 3 times minus 3 will give us the 9. X times x will give us the x squared. And again, we're going to have a plus 3x and a minus 3x that would cancel out. Notice we have no terms in x on the left-hand side. X squared minus 16. Is that a difference of perfect squares? It sure is. X squared has a square root. 16 has a square root. Square root of x squared is x. Square root of 16 is 4. 1 plus sign, 1 minus sign. You can maybe pause the video for a second, distribute, multiply that out. And notice that your plus 4x minus 4x are going to cancel out, resulting in the difference of perfect squares, x squared minus 16. So these are all going to be difference of perfect squares, but start to spot it. X squared minus 25, both x squared and 25 have a clean square root, right? Once you start to spot the pattern, you can maybe get a little quicker with just writing it down left to right, but one last time, let's do it one step at a time. So write your parentheses. Square root of x squared is x. Square root of 25 is 5. And to get that minus 25, the only way that would happen if one of the 5s is positive, one of the 5s is negative. Again, you'll notice if you distributed that out, you'd have a plus 5x and minus 5x that canceled. I want to start to just jump to the answer. Once you identify that it's a difference of perfect squares, x squared minus 36, we can write x plus 6 times x minus 6, and check that. X times x would be x squared. The negative 6 and positive 6 gives us a negative 36, and we'd have a 6x and a minus 6x that would cancel out. Another difference of perfect squares, square root of x is x. We'll go plus the square root of 49 is 7. Same thing with a minus sign, x plus 7 times x minus 7. You can maybe pause and verify that. It's going to multiply out, distribute, and cancel. Your 7x and negative 7x, you'd be left with x squared minus 49. X squared minus 64. Does 64 have a square root? It's 8. So the answer would be x plus 8 times x minus 8. Next one, x squared minus 100. What's the square root of 100? It's 10. So it's x plus 10, x minus 10. Next problem, what's the square root of 121? 11 times 11 is 121. So x squared minus 121 would factor to x plus 11, x minus 11. X squared minus 144. Square root of 144 is 12. Our answer is going to be x plus 12 times x minus 12. And now last one, what's the square root of 10,000? Noticing that 10,000 has 4 zeros, so it's basically 100 squared. So our answer would be x plus 100 times x minus 100. And again, you can verify that last set where we just jumped to the answer. You do want to convince yourself this works. And then you do want to, be able to kind of just jump to the answer for this difference of perfect squares once you recognize it. Just realize that this problem set is all about difference of perfect squares. It's not necessarily going to be the case for algebra in general.